Here we have a ACT math question. Okay, let's go to the information. You need to enclose a rectangular area of land. You have 1000 feet of fence to use for your enclosure. Find the largest area in square feet of the enclosure. Okay, so like our area is in the shape of a rectangle. So let me draw a rectangle over here. So like, and also we have 1000 feet of fencing. Fencing means we'll cover all the four sides of the rectangular area. So that represents a perimeter. That is, for example, if I assume L as the length of the rectangle and W as the width of the rectangle, so the fencing, 1000 feet of fencing will cover the two L's and two W's. That is the boundaries of the rectangle. So this 1000 feet represents the perimeter of the enclosure, that is of the rectangular area. So the perimeter is equal to 1000 feet. And let me know the formula for the perimeter of a rectangle, that is 2 times L positive 2 times W equals to 1000. That is to get the perimeter of a rectangle, we just have to add all the four sides. Okay, here this one is a multiple of 2, this one is a multiple of 2, and this 1000 is also a multiple of 2. Since everything is a multiple of 2, better we can divide everything by 2. So to make the number smaller, so it will make the further calculation easier. So when you divide, so this 2 will cancel, this 2 will cancel. I'm getting L positive W equals to, when you divide 1000 by 2, I'm getting 500. Okay, now I got the sum of the length and width of the rectangular area, that is equal to 500. Okay, our aim is to find the largest area. So already we know that the formula for area of a rectangle, that is the length times width. Okay, now here I got a function for area, but I got the function in terms of two variables, L and W. So if I want to find the largest area, that is a maximum value of this A, so I need this A as a function of just one variable so that I can find its maximum value of A easily. But here we have two variables, L and W. So either I have to get rid of this L or W. So what do we have to do for that? So okay, now let's consider the equation we have over here and let's solve for either L or W in this equation. Okay, now let me solve for W in this equation. For that, I have to subtract L from both sides. When I do so, this negative L positive will cancel out. I am getting W equals to 500 negative L. Okay, now let's write the area again. So that is the area of a rectangle is equal to length times width. Now A is equal to length times. Now for this W, we can plug in the stuff which is equal to W, that is 500 negative L. So 500 negative L. So I'm doing all this work over here to get the area as a function of just one variable so that I can find its maximum value, I mean the largest area. Okay, now I got the area as a function of just one variable, that is L. Okay, now let's simplify the stuff we have over here. So then we get A is equal to, we can distribute this L to this 500. L times 500 will become 500L. And this L times negative L become negative L square. Or it can also be written as negative L square positive 500 L. Okay, so to do further calculation, I have to erase the stuff. Let me erase the other stuff. Okay, here we have the area, that is area of the rectangular region is equal to negative L square positive 500 L. That is, I got area in terms of just length. Okay, now it's a quadratic function and its leading coefficient is -1. What is leading coefficient? So the leading coefficient is nothing but the coefficient of the variable on the right side over here, the largest exponent. So here we have L, here we have L. So this is a term where we get the largest exponent of L, that is 2. So the coefficient means the number we have in front of this L square. Actually, we don't find any numbers, so we have to assume there is 1 over here. So that means -1. So the leading coefficient is -1. So it's a quadratic function and its leading coefficient is negative value. There is -1. So whenever we have a quadratic function with the leading coefficient negative value, so its graph will be a open downward parabola. So usually whenever I sketch the graph of a quadratic function, it will be a parabola. And so like when I sketch a parabola with a negative leading coefficient, it will be open downward parabola. That is, a parabola opens down here. Let me write over here, opens down. And here we have the vertex. So this vertex is a maximum point. Let me write. Okay, so whenever the parabola opens down, we'll have only maximum point and will not have minimum point. Minimum point means we cannot predict because the reason is a parabola keeps going down. So we'll not be able to find where it ends. So we'll not be able to predict where we have the minimum point. So since a parabola opens down for this quadratic function, it will have only maximum point. So we'll have only maximum value for this A, that is the largest area. So how do you have to find that maximum value of the A, that is the largest area? So for that, first we have to find the value of L corresponding to this maximum value of A. So how do you have to find the value of L? So for that, we have to compare this quadratic expression over here with ax square positive bx positive c. So here in this expression, we have variable x, but in our problem, we have the variable L. So a is nothing but the coefficient of x square, that is the leading coefficient. So here a in our problem is the coefficient of L square, that is -1, and b is the coefficient of x, and the value of b in our problem is 500, which is the coefficient of L, so b is equal to 500. Okay, now to find the value of L corresponding to the maximum value of A, there is a formula. What is it? That is L equals to -b over 2a. Okay, now what I need to do is I have to plug in the values for B and A, what I got over here. So for B, we have to plug in 500, and 2 times the value of A is -1. Then we get L is equal to -500 over 2 times -1 will be -2. So this negative will cancel out. I'm getting 500 over 2 will become 250. So when the length is 250 feet, so then the area will be largest. So if you want to get the maximum value of A, you have to use the value 250 for L into this quadratic function. Okay, now what we need is to get the largest area, we have to plug in L equals to 250 into this quadratic function. Okay, now let me do it. Okay, let me plug in L equals to 250 into this area function, that is A equals to -250 the whole square positive 500 times 250. Okay, A equals to negative when I take square for this 250, it will be 62,500. When I multiply this 500 and 250, I'm getting 125,000. So when I simplify this negative 62,500 and positive 125,000, I'm getting A equals to 62,500. So this is the largest area of the rectangular land. So we find 62,500 in option C. So the correct answer choice for this question is option C.